Look at this. Are you ready? 99.03%. That is the solution we're going to be building today. Pretty efficient on memory too. This problem is product itself. It's a pretty cool problem. Love to see my face there. 0.88% of solutions used 18 milliseconds of runtime. That's pretty fast. Now, obviously, not credit to me. I didn't come up with this myself for the first time. This is a proven algorithm, and that's what I want to talk about today. I'm gonna be working on that. So let's go ahead and check it out. Hello from the other side. Welcome back to my channel. If you're new here, well, I appreciate you being here. Thanks for a couple seconds or minutes of your time you have provided me. Thank you so much for being here now. I appreciate it. If you like the content of this channel, if it's the first time and you like this video, please subscribe. It really helps me a lot. I'm just trying to continue my journey becoming a software developer, and definitely having people on the other side either telling me what to do better, telling me what they're expecting, telling me, I don't know, any kinds of things you want to share about software development. If you have tips or questions or anything would really help me as a person and also the channel if you like the video and subscribe. So thanks for being here. Let's go ahead and jump into the main dish. The problem of today is called product of array is sex except self. And honestly, I want to say this to everyone on that side of the screen. I was trying to solve problems live, and I enjoyed that for a few days, right? I was trying just to jump to the problem and see how I would respond to a live situation. And when I mean live, I don't mean live streaming or anything. I did that for a little bit in Twitch, but I'm talking about here. And the point of that was to try to put a little pressure on the process of talking out loud the problem, right? Which is important for an interview. But also like wanting to understand my communication, my thinking process. As probably you already noticed, English is my second language, and I really want to analyze things I say. I really just want to just get better in general, right? And that's the whole point of me doing these kind of videos. But I was realizing that while I was doing all those videos, I was trying to like be too perfect for the screen, right? Because that's what you want, right? You want to project, confidence, and you want to project all these things, but sometimes you don't have that, and that's going to be noticeable even on interviews, and I think that's true for everyone, right? So I just decided to, I got into the medium problems here, right? So I said, you know what? Some of these problems I can't solve live, right? And I don't want to make these videos like 3 hours long, right? Which is fine if if I want to do that, but that's not the whole point of this. So I was like, how can I just make this better? And like a lot of people in the same position I am right now, it's like learning, doing a lot of leak code, just trying to, absorb everything we can. I was wondering, like, can I just look at the solutions? Can I see the video explanation? Can I say all these things? And I realized something, right? How do we learn in school? We don't come up with things that we're on, right? We don't just come up with something and say, oh, yeah, poof, and the solution just pops in our head. We have to go through a process of listening to looking at a whiteboard or a textbook or doing exercises. We have to go through a process to learn the stuff. So when we are afraid to like look up solutions or look at a video explanation or whatever, I think we're missing a big point. If you're not, there are certain geniuses out there. Good for you. Congratulations. I hope I meet some of you one day and learn tons of things from you, and criticism and all that, which is very important. But for the big majority of the people or the vast group of people out there that are doing this thing, hey, we have to find a way to learn, right? So what is the best way to learn? Well, let's go ahead and instead of trying to break our brains, trying to come up with something that's already invented, instead of us understanding it, let's just go ahead and take your time and look at the solution and understand the problem, because at the end I think that's how we are going to be able to learn. It's especially, that's my case, but it's just like I've learned so much now that I take my time to go to medium problems and just, if I can come up with a solution. So what I would do is I just go ahead and bring my whiteboard and try to think about, edge cases if they're needed. I try to think about the data structure I want to use. I try to think about, certain patterns I'm familiar with. So I try to come up with all that, right? And if I see that I'm not going to be able to come up with a solution, I go ahead and look it up and learn, because my process is about learning right now. I have experience in other things, but I have to be humble enough to know that I need to learn, right? So I just try to say, hey, if I'm looking up at the solution and I see that the video explanation is somewhat close to what I got here, hey, I wasn't too far off, right? So bit by bit, I think those reinforcement lessons we do and the effort we put, it comes all together. Like, I cannot explain how much I've learned just by looking up the solution from multiple people. Like, I'm on Nitko right now. He's pretty cool explaining things. But there are also great guys, tons of guys and girls out there doing the same thing. And just look up different solutions, different methods. Like, everyone's gonna have a kind of different implementations of the problem, but at the end, it's like trying to understand the underlying solution. Also, another thing, using AI not to come up with the solution, not to come up with the code, right? Because the code's gonna be there. All you want to do is understand things and ask certain questions, right? So, like, I screenshot the problem and I say, hey, can you help me understand the problem statement? No need the solution, only to wrap my head around what they're asking for, right? Because at the beginning, these questions are kind of vague and too open, and I don't understand. So you just try to like learn, and that's the most important thing. And the reason I'm saying all this is because I think like we want to run before we walk, right? So I think it's important to throw that out there. And if you're in the same process, don't try to skip that part. Learn first. The first time you learn how to add numbers, you didn't come up with that. You had to watch someone doing it, and then you were like, oh, okay, and then you start understanding everything, and that's everything else. Yeah, you're gonna need some basic concepts like data structures, right? You're gonna have to understand data structures to understand why we have to do certain things in an array in a certain way, right? Or a hash table, whatever. But besides that, like, once you're past the point where you understand for loops and you understand data structures and basic algorithms, you're like, okay, I think I can take my time to see how this problem is gonna pan out. And I just wanted to say that. I just wanted to give you that little bit of my opinion, because that's what I've been experimenting. Like, I've learned so much again, and I can't stress this enough. I've learned so much doing these 3 medium problems by looking up the solution and understanding. Like, I look up the solution as I want to, as I was taking a class, an online course, learning completely, not trying to put up a video and be like, oh, this is my perfect solution. No. Actually learn and then try to explain it here. And when I come here and explain it to someone in the other side that know the solution and mine don't know the solution, I'm actually reinforcing all those concepts in my head. I'm drilling them down by explaining it to you in the other side. And yeah, just go ahead and do the code again by myself, and that's just been great. I just wanted to say that because I think we want to skip that part sometimes. But hey, that was a long talk. I never do that. But hey, let's go ahead and jump into the video. I think it's gonna be interesting if we try to solve this problem. I'm going to reset the canvas, and this is the problem. Let's go ahead and read. It says, given an integer array of nums, return an array answer such that answer at that index is equal to the product of all elements of nums except nums of at that index. Okay, and if you haven't seen this problem before, you're gonna understand what I was asking AI. Like, can you clarify this for me? Can you tell me? Just asking questions as if someone was on the other end. The product of any prefix and suffix of nums is guaranteed to fit in a 32-bit integer. That's another thing that's important, right? Like understanding these basic computer science concepts, like how large is that number, right? Like, and really, like, besides that, a 32-bit integer is it's actually greater than it is because half of those bits are used to sign the value. So just basic concepts that you go through and you try to understand too. Some of that you're gonna know from school or online classes you take, but some of that also you're gonna come here and try to study. You must write an algorithm that runs in linear time, or big O of n, and without using the division operation. Lots of hints here, but also very vague for the first time when you don't know what they're talking about. So they give you the first example. You get the integer array of nums right here, which is equal to 1, 2, 3, 4. And then you get the output, let's say answer, as 24, 12, 8, and 6. There's another example, but let's try to understand everything first. So they're saying, this array right here, it's got to be equal to the product of all elements of this array except the number at a particular index. Okay, so how do we determine what particular index? Well, when we are iterating over the array, right? The particular index that we are exploring at the moment we are iterating in that for loop or while loop or whatever, it's going to be excluded from the elements that are producing the product. So I'll go in depth a little more with that. So it's also saying prefix and suffix of nums. So it's talking about, right, what's before this number and what's before this number and also after, right? So as a simple example here, we know there's nothing before this, right? But there's 3 numbers after. Or there's no prefix, but there's 3 suffix, right? And same thing here. This one has one prefix, 2 suffix, and so on, right? So we know we're going to be doing some running calculations, right? And again, that comes from studying this kind of stuff. So we have that. We have the second example, which, we're talking about the product of a number. We have -1, we have 1, we have 0. So we know that from here, we're going to have some 0 values as we see here, because when you multiply a number by 0, right? Okay. So cool. We got those examples. At first, I didn't understand this, right? As I explained before, and I had to go and say, hey, break this down for me a little more. What do I need to look in here? The constraints are very important. So we know that so this is the length of the list that we're gonna get first, or the first array. It's gonna be between 2 and 10 to the power of 5, right? Which it's basically saying, this list is going to have at least 2 numbers in it, because we need to multiply by prefix and suffix, right? We're talking about product. They're talking about prefix and suffix, right? So it says the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Basically saying, hey, these are going to be large numbers, but they're not going to be too large that we are going to need. For instance, if you're using a different language like Java or C++, like you're going to need a different type of integer like long or so forth. And then there's a follow-up question that says, can you solve the problem in constant time? We go of 1, extra space complexity. The output array does not count as extra space. Space for space complexity. So we're talking about the answer array here, and we know we're gonna have to create that because we have the input nums here. So those are the little hints I feel like people that write these problems in LitCode, which I give a lot of kudos to, because I think it's hard to come up with these problems, man. I think you have to know so much about programming, but also you have to know how to not just create the puzzle, right? Not just to know how things are gonna work, but how do you going to word them for people to get hints from it and work on it, right? Anyways, I was opening up a couple hints here. I try not to look at the hints before I look the solution, if that makes sense. Like, I'm not trying to, like, unless I'm trying to solve the problem, once I get to the point where I'm going to be solving mediums, comfortably, I don't know how long, but once I get there and I feel like I'm stuck on something, I'll look at the hint. But really, the hint won't give me anything right now if I don't know what I have to do. So I really just skip the hints. Didn't want to zoom out there, but anyways, when you see the rate acceptance at that number and it's a medium question, you have to know your levels. You have to know what is out of your comfort zone. But anyways, the first thing we have to look is that, and a follow-up is telling us if we can solve this problem in constant time space complexity, and the output array does not count towards the space complexity analysis. So we know that we're going to have to create an output array, which is just going to be the products of all prefixes and suffixes, right? Well, how big is this array going to be? We don't know yet, or we do actually, but what we're going to do is this array is just going to be equal to one element times the length of the input array. That way we know that we're creating an array, basically the length of this array, but is going to look somewhat like this, but all once, right? Because again, every time we're multiplying by a number, if the number multiplies by 1, it doesn't change the result, right? So that's what we're creating right there. So what else do we have to do? Well, we have to find the prefix now, right? We have to find the product of all prefix but the number in question. So how do we do that? Well, we say for every number in, we're going to use the range function with the length functions to iterate over indexes in the array. But what happened is that we know that at position 0, there's no prefix. So what do we do? Well, we can start position 2, right? So position 2 is going to be equal to 1 all the way up to the end of that array, right? 0, 1. Okay, cool. So we move on. Where are we at now? Well, we need to give this first value right here. We need to give it a value. We're not there yet. We're right here, but we are calculating the prefix of this number. So what is product? What is product at that index? So this index right here, actually this index, because that's where we're starting. What is its result? Well, I would say if we need its prefix would be equal to the multiplication of the numbers before. So what's the number before this number? It's going to be whatever it is towards its left. So we're going to say product at position n minus 1, right? We're iterating backwards. We're right here and we're saying, hey, this number right here, it's going to be equal to this number times what? Well, we're looking the product of that number in the array. Let me go ahead and get this array up here too, so it makes a little more sense what we are kind of dealing with. this is just for the sake of the example. So we have like 2 running arrays here. So we know in this case that, this number is going to be equal to the multiplication of this number and this number. So what do? Nums add position n, right, -1. So we go to 2 and we say -1. We're right here. So we know that 1 times 1 is going to be equal to 1. So the resulting array has a 1 here. That's the first case. Then it goes up and it goes up and it's changing that. But what happened is that at the end we're going to have a resulting array of its product that I believe is going to be, so if we do this pretty quick, it's going to be that's equal to 1. This is going to be equal to 3. 2 times 2, this is 1 times 1 equals 1. 3 times 2 equals 6. And then this last one right here is going to be equal 3 times 2, 6 times 1, that's for 4. So let's see here. 1 times 1 equals 1. So 2, 3, so it's going to be 2 times 2, 1, 6. So ignoring that, it will be 4 times 3, okay, because we have a 1 here, and we also have a 1 here. Something we have to think about because they don't have prefix or suffix. So once we hit this number, we say, what's the product of 4 times 3? 12. And then we say 12 times 2, 24, times 1, 24. So we know this is 24. And that's the resulting array after calculating prefixes, right? Now we have to calculate, actually I think it will be easier if I do like this. Prefix equal to that, and suffixes is going to be equal to the result that we're going to do now. So now we have all the prefixes, right here. That's the point we're at right here. What do? Well, our products array already have that. So what do? We're going to go ahead and create a right pointer that is going to be equal to the end of this is going to be equal to the last number in products in our products array, because we're going to be iterating backwards, but we need the numbers towards the right. So when our pointer, for instance, this is just the opposite, but I'll move forward to explain a little. Now we iterate the list towards this way. Now we have to iterate the suffixes this way. This is just the way we're going, right? So how do we do that in Python? So we say, for we're gonna use item in this case. So for every item, and we're gonna do the same thing. Use the range length function here, and we know num's gonna go there. But what happened here is that we gotta iterate backwards. So how do we do that? Well, remember we're adding an extra position to nums, right? Naturally, if we want to have this imaginary 1 here and we want to iterate backwards, we would do -1, -1, -1, right? So, start, stop, and step, right? So we're starting at the last index. We are going all the way to the first index, which would be this, but we're adding an extra one here, and we want steps to be decreasing, so we're decreasing I in this case. But what happened is, since we are decreasing here, since it's not this the case, then here we have to decrease by 2, which means, hey, just go ahead and jump 1 over, which is this one right here. And that's how we're traversing the list with an imaginary 1 there. So what we're going to do here now, well, remember we have the right pointer here, and it's sitting at the last right here. So what's that's going to do? Well, that is going to give me the numbers to the right, the products to the right of the number. Because once the loop goes this way, that's going to stay that way. And then we update, and the loop will go here, and the right pointer will go here, then the loop will go here, and the right pointer will go here. So the right pointer will always stay one behind, giving me the right values, which is what we need, the suffixes. So how do we go from here now? Well, we say, the product of that number at I, so the product of this index right here, which is the n, this one right here, right, is going to be, we're going to multiply times equal. So every time it goes through, multiply this number by what? So we need to multiply 24 right here by the last number in I think this is nums. Products -1, because I'm multiplying yeah, I think this is wrong right here. I think I gotta multiply by nums, because I need to multiply this number 24 by this number, right? So it's gonna be products of I equals right, times equal right, or times equal right, which is nums of -1. But what happened is, now we need to update right, the right pointer, which is going to be multiply times equal. It's got to be multiplied by what? Well, we know that the right pointer is sitting right here at the end of nums. So what we need to multiply it now by, I would say, products, or products, products. Let me make sure I'm using products. I'm just gonna go ahead and change products here for S. You guys probably saw that earlier and said, that guy's not gonna see it. Anyways, multiplying product I times right, and then I'm multiplying right by the product of I don't think this is right, because I'm saying I -1. Let me see, return product. I don't think this is right. No, this is not right. I see what I'm doing here, but let's check the test case. I'm getting 4, 4, 8, and 6. So I'm multiplying the product by its right, which is nums of I. And then I'm multiplying right by products of I. No. Okay, let's see here. Maybe right is gonna stay at products, or product. I've been saying products. It's product, and this is product at that is gonna be multiplied by that number, and then right is gonna be multiplied by right is going to be nums of I. How far are we? A little off. Yeah, we're a little off. I think it's I -1. It might be products minus I, or product. Jesus, I can't spell product. Product minus I. Still off. Right equals product. I think that's nums instead. I'm iterating backwards towards the end. I'm saying product of I, so that product is going to be times equal to the right, so the pointer before. The problem is right here. I'm multiplying right. I gotta multiply right by... I got to multiply right... I was gonna bring the whiteboard. So I need to multiply right by... Right is sitting at products of minus 1, so it's gonna be nums. This is gonna be nums at minus 1. Or nums at I. Yeah, that's gonna be nums at I. No? See, this is the closest one. Right is gonna be equal to... How do I get right? Right? So it's the last pointer. So how do I... The last pointer right is sitting at the last index of nums. And it's going to be multiplied by the running product of I. I think this is it. No. Okay. Okay. This is nums of I minus 1. That's the end of that. And this is nums of I. I think that should be it. Yes. Okay. Phew. That was a good one. See, problems like this will get you. Can you believe that? We still got 98% till like we still got it. Took us a little bit, but it's quite as good as the first one, but it's good enough. Alrighty. This was the problem of today. I hope you liked the video. Hope you enjoy it. Please subscribe to the channel. It really helps me a lot. It really motivates me to continue pursuing this thing and my dream of becoming a software developer. So yeah, just subscribe and like if you like it. If not, just let me know what can I get better. Drop some things in the comment there. Just let me know, if not just for the sake of commenting, but something of value. So yeah, if you like the video, please support me, and I'll see you in day 12. This was day 11. See you in day 12. Give me that confetti. Let's go.